Hello students, my name is Vijayan and I welcome you all for today's program, which is going to be on the first part of the chapter of simultaneous equations. At the end of today's program, you should be able to identify and use simultaneous equations, solve simultaneous equations using the graphical method and the substitution method. Before we get to know what simultaneous equations are, actually, let us make a brief recap on what equations themselves are. Equations are statements whereby an unknown value is to be found. This unknown value is often represented by x. I am sure you can still remember equations where most of the time we had to find x, but let us consider a simple example that will help you recall. So we are to solve the equation 2x plus 4 is equal to 10. I am sure you can do it and you can find the answer for x. So let us see whether you have correctly found it. The solution is x is equal to 3. Yes. One thing to note is that this value is the only value which satisfies the equation. That is, if we put x is equal to 3 on the left-hand side, it will give us the value 10 on the right-hand side of the equation. This value is unique. Now let us consider a second situation where in fact there are two unknowns. X plus y is equal to 7. The unknowns here are x and y. Here we will get a pair of value of x and y as solution for the equation. However, there are many such pairs. Let us see some examples. As you can see, x is equal to 1 and y is equal to 6. There are values which satisfy the equation. But at the same time, we can get x is equal to 2 and y is equal to 5. Another pair of value that fits in the equation is x is equal to 3 and y is equal to 4. We have an infinite number of such pairs for such an equation which contains two unknowns. Now let us consider two such equations. The first one is x plus y is equal to 7, and the second one is 2x plus 3y is equal to 18. For the first equation, we have seen already a list of pairs of values which satisfy the equation. In the same way, we have a list of pair of values, which is again infinite for the second equation. For instance, x is equal to 0 and y is equal to 6 is one pair which satisfies this second equation. Interestingly, one of these pair of values satisfies both equations. Yes, you have clearly identified this pair as x is equal to 3 and y is equal to 4. So x is equal to 3 and y is equal to 4 are the values that satisfy both equations given. We say that x is equal to 3 and y is equal to 4 are the solutions of the simultaneous equations. This brings us to the definition of simultaneous equations. Simultaneous equations consist of a pair of linear equations which is satisfied by the same value of the unknowns. When we are asked to solve simultaneous equation, it simply means to find the value of the unknowns which satisfy both equations at the same time. The methods that we are going to consider at this level to solve simultaneous equations are the graphical method, the substitution method, and the elimination method. For today's program, we will consider the first two methods. The graphical method. As the name suggests, this method consists of graphs. In fact, we will draw the two given lines on the Cartesian plane and locate the point which is common to both lines, that is, the point of intersection of the two lines. If this appears to be complicated, let us consider an example. Solve the simultaneous equations x plus 2y is equal to 10, 2x plus y is equal to 8. Before we proceed any further, I would like you to recall that to draw a line, we need at least 2 coordinates on that line. And to find these coordinates, the usual way to do it is to construct a table of values. So this is what we are going to do for the two lines. For the first line, x plus 2y is equal to 10. This is the table of values, and we get 2 coordinates, which are 0, 5 and 2, 4. For the second line, in a similar way, if we construct a table of values, we are going to get 2 coordinates, 0, 8 and 1, 6. Now we can draw the two lines. So this is the first line that we have drawn on the Cartesian plane. You should label it because the second line is going to come on the same diagram. 2x plus y is equal to 8. Now you can clearly see where the lines intersect. We are going to read this coordinate. This coordinate is 2, 4. As the point of intersection is 2, 4, the solution of the simultaneous equations is x is equal to 2 and y is equal to 4. So this is the graphical method where you have to draw the two lines. Now you will need a lot of practice for this, but you should note that you may use GeoGebra once you have drawn the lines on your graph paper to check whether you have correctly drawn the lines. Here are some exercises that will enable you to have some practice. The first part, x plus y is equal to 3, 2x plus 3y is equal to 9. Second part, 4x minus y is equal to 7, 2x plus y is equal to 5. Part C, 3x minus y is equal to 6, and x plus y is equal to minus 2. And part D, x plus 5y is equal to 2, and 2x plus y is equal to minus 5. So these exercises, you will have to attempt them using the graphical method. Now let us proceed to the second method, which is known as the substitution method. Have you ever heard of substitution? If I talk about a substitution in a football match, does it tell you something? Yes, it is when a player comes off the field and another one replaces him. The same idea for substitution is used here in this method. But however, here are some steps that we will have to go through to use this method. The first step would be to label the equations. The second step would be to choose one equation and to make one unknown subject of formula. Once you have made the unknown subject of formula, you are going to replace it in the other equation. The fourth step would consist of solving this equation, which now involves one unknown only. And the last step, you have to remember that you have to find the value of x and the value of y at the same time. So both unknowns have to be found. Let us take an example to illustrate this substitution method. We are asked to solve the simultaneous equations x plus 3y is equal to 8 and 2x plus 5y is equal to 13. Let us proceed with the solution. The first step would be to label the equations as equation 1 and equation 2. Now, if you have a look at the equations, you will see that from equation 1, x can easily be made subject of formula. And this is actually what we are going to do. From equation 1, x is equal to 8 minus 3y. So we have already done the step where x has been made subject of formula. Now we are going to replace this in the other equation, that is in equation 2. One advice from me is that you should look at equation 2 and see properly where the x is, that is where the letter that you're going to take out is, and you're going to replace by 8 minus 3y. So we are going to take this x out and we are going to replace it by 8 minus 3y. This is done using brackets. Now you see that the equation consists of only one variable. So we can solve this equation now, and it will lead us to the value of y as 3. Once we have found the value of y as 3, we are yet to do the last step, which involves finding the value of the other unknown, which is x. So I will use any one of the two equations and replace the value of y by 3. From equation 1, replacing the value of y by 3, we get x as minus 1. So students, this is the solution of our simultaneous equation. X is equal to minus 1 and y is equal to 3. One good advice again would be that you take the habit of verifying whether your solutions are okay, are good. You take x is equal to minus 1 and y is equal to 3. You replace in both equations. Both equations should be satisfied. Let us proceed with a second example. Solve the simultaneous equations 3x plus 2y is equal to 10 and 2x plus y is equal to 6. Now again, the first step would be to label the equations. Now if you have a look at the equations, you will see that y from equation 2 can be made subject of formula easily, and this is what I have done. Y is equal to 6 minus 2x from equation 2. So now we are going to replace this in equation 1. Again, before you do the substitution, it would be good that you identify what is the letter that you're going to take out and you're going to replace by 6 minus 2x. So this is the letter that we are going to take out, the y, and we are going to replace it by 6 minus 2x, again using brackets. This gives us an equation which consists of x only. Now we move on to solve this equation and we get x to be 2. The last step would be to find the value of y. Again, you can use any one of the two equations. From equation 2, using the value of x as 2, you are going to end up with y is equal to 2. Again, the good advice is that you verify your answers. Put x is equal to 2 in the first equation at the same time y is equal to 2 in it and see whether it gives you 10. Put x is equal to 2 and y is equal to 2 in the second equation, see whether it gives you 6. If this is the case, it means that you have correctly solved the simultaneous equations. So with these two examples, now there is a series of questions for you to practice using the substitution method. Solve the following simultaneous equations using the substitution method. First part, 2x plus y is equal to 7. 3x plus 2y is equal to 11. Part B, 3x minus y is equal to 11. 5x plus y is equal to 21. Part C, 4x plus 3y is equal to 2 and x minus y is equal to 4. Part D, 2x plus 3y is equal to 9 and 3x plus 2y is equal to 6. To summarize, in today's program, you have been able to identify and use simultaneous equations. You have also learned about two methods, namely the graphical method and the substitution method. Here is a list of some links that you might find helpful in understanding what we discussed today. This is a second link. And there is a third one. Well, students, this is it for today. I hope that you have enjoyed this program and found it helpful. Until we meet for the next part of the program, for now, it is goodbye from me and see you soon.